Hello everyone and welcome. Thank you for joining us for a special edition of Sync with an Expert. I'm Nadine Flanagan, Inside Sales and Sales Operations Manager at Safran Trusted 4D, and today we're taking Sync with an Expert on the road. For our sixth episode, we're coming to you from Boulder, Colorado, where we're joining the Infleqtion team to introduce something we are genuinely excited about. The partnership between Infleqtion's Tiqker quantum optical clock and Safran's secure sync and White Rabbit timing technology. This is an exciting moment because it brings together two powerful strengths: Infleqtion's work in quantum precision timing and Safran's trusted experience in secure, resilient synchronization systems. All of that matters because timing is no longer just a technical requirement in the background. For many critical systems, timing is what keeps networks aligned, operations moving, and decisions reliable. Even when GPS or GNSS signals are degraded, disrupted, or unavailable. Today, we will hear directly from two experts who can help bring this to life. From Infleqtion, we have Pritesh Solanki, VP of Time and Frequency Solutions, and from Safran Trusted 4D, Dave Sohn, Chief Engineer for Timing. Together, they will walk us through what Tiqker brings to the timing landscape and how it pairs with Safran's secure sync technology, and why this partnership opens exciting possibilities for customers who depend on accurate, resilient, and trusted time. After the presentation, we will open it up for a live Q&A. Please continue submitting your questions throughout the session using the Questions tab, all at the bottom of your screen. We will answer as many as we can live, and if any questions require a deeper follow-up, our team will connect with you after the event. You may also see a few quick polls along the way. These help us learn more about your timing challenges and tailor the conversation to what you care most about. We're excited to have you with us for this episode, and we are especially excited to share this partnership with you from the Infleqtion team's home base in Boulder. With that, let us get started. And I'll hand it over to Pritesh and Dave.
Thank you, Nadine. Happy to be here. This is now our sixth Sync with an Expert, and this one is kind of a milestone for us because we've taken this on the road to Infleqtion here in Boulder, Colorado. And with me, as Nadine said, is Pritesh. Welcome. Thanks for joining me. This will be an exciting ride. I get really excited about this technology. But, first off, tell me a little bit about Infleqtion. Who is that? Who are you?
Yeah, so Infleqtion is a leader in quantum computing and quantum sensing, powered primarily by neutral atom technology.
So what is neutral atom technology? Explain that a little bit.
Yeah, so neutral atom technology are typically using atoms like rubidium, also cesium.
So, I am familiar with rubidium and cesium.
Yeah.
So what about them makes them ideal for what you guys do with them?
It's a very stable atom, so we don't have to cool it down to very low levels. So the way a lot of our systems operate, specifically our clocks, is we heat the rubidium atom to a vapor.
Okay, all right. So coming back a little bit on Infleqtion and how you got to what you guys are doing now.
Yeah, we actually started building vacuum cell technology as a kind of a picks and shovels type of business, and we grew from there into quantum computing. And then as we started to expand, we are now in the business of quantum sensing, which is our kind of short-term goal as far as getting products that utilize quantum technology into the market today. And as we build a lot of those quantum sensors, we're able to help commercialize a lot of that, develop our product development skills in that, which then ultimately allow us to bring the quantum computer to market.
Okay, so starting out a little bit smaller, so starting out as almost the components for quantum technology.
That's right.
And then looking at how can you bring that into market. So at first was selling to customers to the market in that, and then now expanding into building systems with that into really the first commercial side of that in the quantum sensing.
That's right.
Okay, so now what are the quantum sensors you're working on? What are we working with you?
Yeah, that's a great question. So right now, one of our main commercial products is Tiqker, which is our optical atomic clock. This system actually started off as a DARPA contract to over 4 years ago to basically bring a optical atomic clock to the marketplace. Since then, we've basically done over 4 different design iterations, each time improving a different aspect of the system, ranging from our performance to control systems, and now we're really focused in on our manufacturability. So this technology is not just a breakthrough in physics, but also the ability to turn optical clock technology into a repeatable product that can be scaled.
So some of our customers and those that work with our products are familiar with atomic clocks, like the Rubidium clocks that we use within Secure Sync and those. What's that technology versus the Rubidium optical clock technology that you're talking about?
Yeah, so the incumbent technology is typically microwave Rubidium-based clocks. And so you are interrogating the atoms with a microwave signal. So back in 1999, with the introduction of what's called an optical frequency comb, it enabled the door for interrogating atoms at much higher transition frequencies, specifically things like laser wavelengths. So what we use is typically a telecom grade 1556 nanometer signal that we use to interrogate the atoms.
Okay, so but what's the value? What's the difference of interrogating at the microwave frequencies versus up at the optical frequencies?
Yeah, that's a good question. And the way you can look at it is it's kind of a ruler with more ticks on it. So with the microwave clock, you basically have a ruler with very few ticks on it as compared to an optical clock, where you have much finer granulation on that ruler. So what that enables you to do is create a cleaner, more stable signal.
Okay, so you're improving essentially how well you can measure and steer into this atomic signal, going from with the same atoms, the same type of atoms, going from the microwave up to the optical level. Right. Okay, and then you had mentioned that there was a breakthrough in technology to actually allow us to do that, because we've been working with optics for a long time, but still in our, let's say, in the practical world of electronics and having to use it, in digital space and what we can easily manufacture. What changed? You talk about the optical frequency comb. So what is that? What does that do?
Yeah, so generally, like you had mentioned, when you're using microwave frequencies, most electronics today all use electronics that can pick up RF and microwave frequencies, right? But when you're using optical, it becomes a little bit more difficult. So that's generally why optical clocks have been kind of out of reach. With a optical frequency cone, what that allows you to do is go from the optical regime back down to the RF regime. So it basically acts like a ruler for light.
Okay. So it's really the piece that allows you to convert all the accuracy that we can get in the optical domain, but be able to bring that into the level that we can use with I don't want to say regular equipment, but the equipment that's and electronics that are widely available today.
That's right. And the way our system works is we lock our laser to the atoms because we can trust those atoms. It's the same species as what you're used to, like rubidium. Once we have the lock laser, generally you cannot find electronics that can convert those photons into electrons, right? Because the frequency is up to 193 terahertz. So when you have the introduction of an optical frequency comb, that allows you to actually lock the frequency comb to our locked laser. And that frequency comb basically gives you a full ruler for light. And then you can take that 193 terahertz signal and bring it back down to something more usable, like 100 megahertz, 10 megahertz, or 5 megahertz.
So when we look at an optical clock like the Tiqker, we talked about some of the let's say the main components, the main parts of that system. So you have the, obviously the atomic element there. In this case, it's rubidium. Then you have the laser you were talking about that you stabilize and lock to the rubidium optical transition. Yeah. And then you're taking that laser and that goes into the frequency comb. And what else is in Tiqker?
Well, I mean, you pretty much nailed it. I think you might be the expert now.
Well, they have me here for a reason, I guess. I don't know.
No, I mean, there's other things involved with it, but you highlighted most of the key elements. Once you get your RF signal out of your frequency comb, now you have a very stable RF reference.
Okay.
Now we have a lot of other components in the system that largely revolve around control of the overall system. So maintaining temperature, maintaining the frequency that we're trying to interrogate the atoms with, and largely just making the system operate like a clock would.
All right, so it's taking what might be, let's say, a lab system, an experiment, and bringing it so that it is really commercialized and is a real product, right? So all the control systems that go around that, the interfacing, the measurements and monitoring of that to manage that quality. And you had talked about the iterations that you went through to kind of get it, let's say, from that development, from that benchtop type of system into something that's deliverable, right, and repeatable. You said that first it was kind of focusing on getting the components together, and it was on some performance aspects, and then quality aspects, and now a lot of design for manufacturability elements. So really building in that quality in the manufacturing process and the production process to be able to deliver these out into industry.
Yeah, and that actually is what separates Infleqtion from some of our competitors. We spent a lot of time thinking through how do we make these kinds of systems deployable in real world conditions, so that way we can take them out of the lab and use them in actual real applications today. So we've thought through a lot about what it takes from going from a physicist building a system to a technician building one. And so a lot of once we've understood the physics, once we established all the control system, a lot of work went into just the mechanical design of the box, how we do everything from our cable management to fiber routing to making sure that the system can be assembled by either Infleqtion technicians or later contract manufacturers. So it gives us the ability to really scale the product line.
Okay. And so not just for production, but also for tasks for repair, for service as well, right?
That's right. Yeah, so we've built our system to be very modular. We have several different subsystems within the overall system such that we can build and test independently. So we're able to introduce quality assurance checks all along the actual assembly process. So we can do individual subsystem component testing to subsystem testing all the way to full system testing.
Okay, and all that is set up here in production, right?
That's correct, yeah.
And I love that you said modular. People who know me, listen, I love modularity. I love the being able to take those building blocks and put those together in smart ways, which looks like that's what you've been doing with the Tiqker to get it to where it is today.
Yeah, and you touched on something that's really important is maintainability and serviceability. So all of our components can actually be swapped in the field as needed. So that allows us to offer better service plans to our customers. If we have issues in the field, we can do over-the-air software updates as needed, as well as changing hardware in the field.
Well, I love that because here at Safran, we're very customer focused, very key on the customer experience, not just what they're getting with the product, but as they're using the product and working with those in their applications. So, and I have my thoughts with why would you say that Safran and Infleqtion have come together?
Yeah, that's a great question too. Infleqtion provides a really stable reference when it comes to Tiqker.
Okay.
But as a individual or component, there's only so far we can reach. So the partnership here allows us to expand the overall integration platform to include things like your Secure Sync 2400 and White Rabbit. So with the Tiqker system offering as your kind of local heartbeat, Secure Sync basically acts like the intelligence to take in your GNSS signal, to also orchestrate any type of failover and kind of act like the overall orchestrator of the system. And then White Rabbit offers your time distribution fabric.
All right, so I like I like that. I like hearing our products, right? Working with others. So we have the Tiqker as that ultra stable heartbeat for this timing distribution, this timing system as a whole. You have Secure Sync and our other products are acting as that reference, bringing in the Tiqker, bringing in other references, GNSS, PTP, NTP, other White Rabbit systems, plus then the distribution, because as we've talked about in some of the other Sync with an Expert it's not just about getting the timing to this point, you have to get it from there out to where it's used, right?
That's right.
None of this happens in a vacuum. Right, it's taking it in and then bringing it out to where it actually needs to be used.
Yeah, don't talk to me about a better second unless you can distribute it, right?
Right, exactly. And so let's talk about where are these used? So what are the applications for this?
Yeah, so anywhere that you need anywhere a system could be dependent on GNSS, and where the system cannot stop just because you get a GNSS interruption, that's where Tiqker and this overall system could be very useful. There's also a lot of applications as far as wherever you need better stability, low phase noise, and longer term holdover. This is where Tiqker is a perfect fit. So some examples of this would be radar platforms, data centers, and even the financial industry can leverage this for high frequency trading and trying to deconflict orders.
Okay, so those areas that are really looking for this stable performance over longer periods, where there may be a contentious environment, if we're talking about maybe in the defense space, or even in some commercial applications where we've seen interference on your, let's say, primary reference, and a system with something like the Tiqker then allows you to go through those and help smooth that, maybe even improve that input as it's coming into the system, even in the normal case. Those are the applications. But what does that solution bring to the customer? What's the value they see in maybe what they bring to their customer, to their application, right? So we're improving the timing. We've talked a lot about that with Sync with an Expert, that timing is kind of a, let's say, this kind of infrastructure piece, right? And we bring the value of that timing to the user's application, and then they turn that value into the value to their business, to their their market, their mission that they're doing. So what does the stability of the Tiqker translate to in, let's say, radar or communications?
Yeah, so if you look at radar is a good application for this, because if you have nanoseconds of timing error in your system, that can actually translate to meters worth of positional error, or meters worth of velocity tracking. So, given the nature of how the threat is changing today, that can mean the difference of hitting your target and not. So what Tiqker offers that incumbent solutions do not is, rather than nanosecond error, we're offering picosecond level error. So it's a full order of magnitude of improvement, which basically gets us down, depending on the type of radar system we're talking about, and get us down from tens of meters of error down to single meter error.
Okay. So now outside of the defense space into, let's say, a commercial application like communications, what does that mean to communications?
Yeah, so I mean, as you're starting to jam more symbols or more bits into your data stream, and as you're trying to transmit out more, increase your bandwidth as a telecom provider, timing here really matters because more timing error will mean more noise in your system ultimately. So less timing error allows you to pack more of those bits in that data stream.
So I guess what I'm hearing a little bit in communication is with Tiqker, with precise distribution of that, you can get more bandwidth out of your existing systems. You get less errors in that, and I assume that turns into more money for that customer, right?
Yeah, I mean, we all want more data. We all want to stream more things. But the technology
that doesn't seem to be going down. It just seems to be going more, right?
Yeah, we have more devices in the house than we ever did before. There are more mobile devices out in the public more than there are before. And so as a lot of telecom providers are going from even 5G to 6G, picosecond level synchronization, timing become more and more important here.
Yeah, I know on a previous Syncline Expert we talked about White Rabbit and how what White Rabbit is really bringing is that distribution piece, is taking the accuracy that you have, the performance you have at point A and getting that out to point B and all of those points, right? And also we talk about the picosecond level sync, the sub-nanosecond level sync. And so that seems to be a great fit of the performance of White Rabbit being able to distribute the performance coming out of Tiqker.
Yeah.
Now, okay, so we talked a little about defense, communications. You mentioned data centers and in financials. So the fintech is another market that Safran has played in for a long time with White Rabbit. What's Tiqker in the financial space, right?
Yeah, so it kind of all goes back to timestamping.
Okay.
And as you are able to go from nanosecond level timestamping to picosecond level timestamping, you can do things like deconflict different orders that are coming in and put those orders in the correct sequence. That's one of the main drivers for this.
Yeah, so I mean, I'll kind of make a strange analogy, but you talked about the radar and kind of acquisition and targeting granularity and how tight you can get that. A little bit similar in finance, the real value in the observability. So the observability, how small of a slice of time can I do to see the difference between data A and data B, transaction A, transaction B, and use that intelligence to make my own decisions on financial transactions, et cetera. And of course, also turning that into money for them and their customers.
Yeah, and there's two kind of classes of improvement you get out of this. Like one is your GNSS redundancy, because those types of institutions cannot tolerate GNSS disruptions. Okay. So if GNSS goes down, you don't want your operation to halt. So here in that case, what we talked about with the Secure Sync, White Rabbit, and Tiqker combo, Secure Sync can automatically fail over to Tiqker as your reference, so your operations can continue. And then the other kind of regime of improvement you get is what we talked about with timestamping. So now with Tiqker, you can get down to the picosecond level timestamp. So that gives you much greater granularity in looking at those different orders as they're coming in.
So where is Infleqtion fit today? Where are you guys already installed and are looking at?
Yeah, so Tiqker is used in a lot of different frequency reference labs. So, we'll sell into any type of lab that needs a very stable frequency reference to do clock-to-clock measurements or just to stabilize their system, either with our optical outputs or our RF outputs. And we've also done a lot of field trials that basically demonstrate our deployability, ranging from field exercises with the DoD, We've done trials with the Navy in the submarine. We've also done some flight trials just to see how Tiqker performs under different pressure
Well, those are difficult situations, right?
Yeah,
Difficult
definitely.
environments to operate in.
And so being able to stay locked and performant is very important to us. And all of those really lead us to the next set of applications, which range from radar systems to data centers. Fintech is a very important one, and telecom. And this is a great example of the work that you and I had done together a few months ago with Quantum Corridor, which is building out data centers for quantum-enabled technologies like ours. And they had a 20-kilometer fiber running from Indiana to Chicago that we were able to connect Tiqker and White Rabbit and Secure Sync and transmit that timing signal across fiber that's actually buried under real-world conditions.
Yeah, and measure the performance aspect of that across that link, the round trip link, so that we could measure both ends of that and see the quality from the starting point from the Tiqker, and then what we were able to achieve through distribution of White Rabbit coming back around.
That's right.
Yeah. And what's the technology in use today, and how's the performance of Tiqker bring value in comparison to that technology today?
If you have anywhere you would find a microwave clock, you can install a Tiqker and achieve a much greater level of stability than you could before. And if you also have maser level requirements, but you're constrained with size, weight, power, and price, this is where Tiqker really shines. One good example is satellite communications, right? Like as we start to put more and more satellites into space and they get further and further out, think lunar communications potentially. As we want to communicate with systems like that, you need a more stable reference, you need lower phase noise, you need longer integration time because of the time it takes for you to send your signal from the ground to that satellite and back. These are all greater demands on your timing infrastructure.
Okay. I guess maybe some practical piece. How do you connect? How do you interface with Tiqker? What is that?
Oh, sure. Yeah. So I mean, there's several ways to interface with Tiqker. We have a Skippy interface, which some people still love and use, but we have a web UI where basically we have an Ethernet port that you can connect on Tiqker. We have a basically custom UI that basically tells you status of the system. It's a pretty simple system. It's kind of a set and forget.
Okay.
Ideally you turn it on and it goes through its sequence and locks up.
And it just works.
And it just works every time.
And so what are the signals? So what am I taking from Tiqker? So you talk about frequency.
Yeah.
So how am I guess, taking advantage of Tiqker? What am I connecting? Right?
Yeah. So there's a few different ways depending on your application, of course. But the system right now provides 3 RF outputs. So you have 100 megahertz, a 10 megahertz, and a 5 megahertz. We also provide 2 PPS outputs. And we have a sync input. So if you have a GNSS source that you want Tiqker to steer to, you can do that. You can also take the Secure Sync's output and steer Tiqker to that. We also offer a 1556 nanometer optical output, which some customers really appreciate, especially for laser locking applications. So if you have a laser or an optical setup that you need a stable reference for, you can actually tap directly off of our optical output, which again, that output is locked to our atoms, and then stabilize your system using that. Okay,
so we have the laser output, which is that ultra stable laser that you've locked. We have say frequency outputs like 100 megahertz, 10 megahertz, 5 megahertz, and then traditional digital outputs like a 1 PPS.
That's right.
And you said there's a synchronization input so that you can not just have a frequency source, but also have a phase aligned source as well, right?
Right.
Because that's the key for us in the timing is both the phase and frequency aspect of this, right? Okay, well, What else do you have? What do you?
Yeah, I mean, there's a lot going on in our product development space. So, Tiqker Prime is sort of our first product right now. Like I said, it's a 3U rack-mounted system. But as we progress in our product development journey, we're looking at a cost-down variant of this system. We're also looking at space-based applications. And even further out, we're looking at photonically integrated systems that basically shrink Tiqker ultimately to chip scale.
Oh, well, so saying you could take a Tiqker and embed that within a Safran product.
That's exactly right. Just like kind of how you guys are doing it now, but you have a microwave rubidium clock in your systems. So in the future, you'll have a Infleqtion chip scale optical clock in your systems.
Oh, I love the sound of that.
Yeah.
And with that, I think it's a great time to hand it back to Nadine and some live questions.
Thank you, Pritesh and Dave. That was excellent. And we really appreciate you walking us through Tiqker, SecureSync, and how this partnership brings together quantum precision timing with trusted synchronization technology. What stands out most is the focus on resilience, accuracy, and continuity, helping customers think beyond traditional timing sources and toward solutions designed for environments where timing really matters. We will now move into our live Q&A session. This is your opportunity to ask our experts questions about the partnership, Tiqker, SecureSync, resilient timing, and how these technologies may apply to your own timing needs. If you've not submitted a question yet, you can still do that now using the Questions tab at the bottom of your screen. We will answer as many as we can during today's session, and if we do not get to your question live or it requires a more detailed response, someone from our team may follow up with you directly. With that, I will hand things back over so we can get started with your questions.
Thanks, Nadine. All right, we'll get into the question portion here. If you do have more questions, we're still taking them in, so please ask them. If there are things that come up even after the webinar, there was a link below. We'll also have a link that we'll put on at the end. Just go to the website, fill out the form. Your inquiry is of course important to us. We want to answer these questions. We love getting questions from customers, from our markets, and then we will of course get back with answers. Oh, this one is exciting because you might get an answer from Infleqtion, might get an answer from Safran. I mean, yes, we'll see.
Let's do it.
Yeah. And then another note, this is being recorded, so if and we might go over the hour mark. I see there's a lot of questions already, a lot of excitement here. And you can feel free to stay on or be recorded, and you can come back and look at answers later. Let's get right in, right?
Okay.
Okay. We'll start here. A rough estimate of how Tiqker, let's say, compares with active hydrogen masers, pricing, size, that kind of thing. We touched a little bit on it, but maybe kind of revisit a little bit.
Yeah, so Tiqker is roughly half the price of a hydrogen maser in a much smaller form factor with comparable performance. Obviously, that'll depend on quantity, service that you'd expect from the system, and just the overall system configuration. So specific inquiries should be managed through Infleqtion or Safran sales. Yeah, and as far as availability goes, Tiqker right now is currently in production. We typically quote a 6-month lead time for any POs, but again, that varies depending on what your application is. So if you have an urgent need, reach out to us and we'll discuss it further.
Yeah, and in the same way, like with Safran orders and that for large opportunities, to reach out and then we'll can work on specifics for that kind of thing, right? Yeah. So where would you see the Tiqker optical clocks in comparison to masers or let's say microwave rubidium, cesiums, in terms of applications?
Yeah, so that's a great question. Anywhere that you would have a standard rubidium or a cesium system, you can basically take an optical clock-like ticker and install it one for one. The biggest difference is that you're going to get the hydrogen maser level performance with ticker that you wouldn't get with the standard option.
Yeah, very precise short-term stability and performance that that you get with the Infleqtion.
That's right.
The ticker. So here's one that I like, right?
Yeah.
So how can ticker integrate with Safran products and provide a single timing infrastructure? So we did talk about this a little bit in the before, right? So we think of, I think the ticker is that primary reference, right?
Mm-hmm.
And we have the secure sync that can act as the intelligent piece to bring and route that the ticker performance, as well as other input references, and then distribute out with the different outputs from secure sync or through White Rabbit products for that, maintaining that end-to-end timing performance out to the end usage, right?
Yeah, and typically ticker will output the 10 megahertz signal, which gets fed into the Safran secure sync, and then you would distribute it from there.
Yeah. Here's an interesting one about how the ticker can be used in quantum applications. So ticker we talk about itself is in the quantum application area, right?
Right.
But what about how it gets used, the kind of benefits you can get with using a ticker when looking at quantum application, quantum networking, and
right. And so with quantum computing, you're going to be using a lot of lasers in your system. So that's why we touched on the 1556 optical output on the back of ticker that can be used to stabilize all of the different lasers in a quantum computer. Quantum computers also will leverage GPS discipline oscillators. So anywhere you have one of those systems, you could basically put a ticker in place of that. And that'll give you much better synchronization capabilities.
right. So that short-term performance from the ticker, that stability and that precision can support the quantum infrastructure, just like the timing infrastructure would now, but with that level, that extra level of performance, right?
Exactly. Right.
So let's see. Correcting, that's interesting. So this is kind of a little bit in the application, right?
Yeah.
So when you're using multiple timing outputs, right? So you have a single source and you have multiple timing outputs, managing the latency to different endpoints.
Mm-hmm.
Now, I guess I'll answer this first part, right? Is ticker is kind of that primary reference, right? So it's not meant to itself do the distribution out to all those nodes. It's the primary source that feeds into distribution that then does that.
Mm-hmm.
And so to manage latency at different endpoints, a device like Secure Sync that it's connected with has the ability to offset the outputs, one versus the other, or some of the protocols already have managed that latency, like White Rabbit manages the latency going across that distribution. And the second part here, this is like a little bit of application, using the ticker in, let's say, higher frequency applications. So this one was asking about a 10 gigahertz application. So, the outputs we talk about from ticker, you have the laser we just mentioned, right? 100 megahertz frequency, 10 megahertz, 5 megahertz, and the PPS.
Mm-hmm.
So talk about how using on when they have to multiply that up, what are...
Yeah, so obviously it depends on the application, but the highest frequency that ticker can provide is 100 megahertz. So if you're interfacing to a 10 gigahertz system, you would have to introduce some kind of frequency multiplier. So anytime you're going to multiply frequency, you will have an impact on your phase noise. So this could likely, just going from 100 megahertz to 10 gigahertz, it's likely going to increase your phase noise by 40 dB or so. What I would say is that, if you have this particular need, reach out to us because there are development efforts ongoing with how we operate our optical frequency combs that could enable us to do a direct 10 gigahertz output.
That's one of the actual amazing things about the frequency comb technology is that ability to kind of tune from the optical side to the output side, whether if it's in the microwave space or even still in optical, to adjust that frequency that's coming out on the other end, right?
Yeah, and like we talked about before, it's a ruler for light, so we can really select which frequency that we want to output.
Right. And so this is a same as a typical application where the primary reference is acting as the LO into some system, whether it's radar, communications, or things like that, right? And these are things that in general have to be aware of is as you go up to that higher frequency for the transmission, for the emitter, the noise, the inherent noise is going to be multiplied up as well.
That's right.
Right. There's one about, let's say, the lifetime of a ticker, right? So you deploy a ticker. What are the expectations of a customer in terms of that life cycle?
Yeah, so I mean, we've designed the system to support more than 10 years of operation. We don't have our MTBF spec right now, but we are actively qualifying this in our current development. So as we mature the product, we will expect to get a 10-year MTBF. But as of today, we like I said, we designed the system to meet that criteria. A lot of our components exceed that criteria. And we also support our products with various levels of warranties, so ranging from 1, 5 to 10-year warranties.
No, that's great. And that's one of the things with this partnership, right? So Safran, ourselves, we're very, very proud of our support, our service capability to the customers, right? Here's one talking about lunar applications.
Yeah.
Right. So now the current ticker, right, is not not space qualified. It's a terrestrial.
Tiqker Prime today is a terrestrial product, but we are actively working on a space qualified variant of Tiqker with some major partners of ours.
Well, that's exciting.
Yeah.
Right. Here's kind of we talked about this in a couple times, right? The difference between current clock technology, so microwave clock technology, and optical clock technology. What is making this so much better in terms of performance with comparable species of atoms in microwave space?
Yeah, and I think that's a good point. It's not really a difference between atomic and quantum. It's all kind of quantum. It's a difference between a microwave frequency and an optical frequency. So it's the same species of atoms, which is rubidium, but with traditional microwave clocks, you would you would interrogate the rubidium atoms at a microwave frequency. With Tiqker, we're actually using a laser to interrogate the atoms. So we're at an optical frequency, which is much higher, which means once you actually come back down to the RF, you're dividing out a lot of noise out of the system, which is where you get that inherent stability from.
Yeah. Let's see. Here's another one. We kind of answered this on accepting orders and lead times. And so we're accepting orders.
We're accepting
order
orders
now, right? And talked about lead times. And we mentioned a little bit about deployments where we have deployments already. We revisit that, without going into specific customers and things like that. But what are kind of the applications that they're deploying in now?
Yeah, so we've done various demonstrations with in the national security sector. We've also done demonstrations and deployments for data centers across real world fiber that's been deployed. We've done maritime demonstrations, flight demonstrations. So we have a lot of deployments currently out there. There's obviously the national labs and the timing laboratories that we have systems at.
Yeah. So this one's around a little bit architecture. Does Tiqker operate as a primary timing reference, as a GNSS independent holdover source when GPS or GNSS is unavailable, or both, and sort of that transition? And I guess I'll take a little bit. Well, I'll let you answer this. It's obviously primary reference.
That's
right. And it has that sync input to use to synchronize. And so it's both, right? And,
That's right.
Yeah, so it's really both, and it's dependent on the application needs, specifically. Also some, I mean, even some, it might be regulatory needs or things like that, whether it's you have a requirement for GNSS independence. In that case, you might have the ticker as actually the primary reference that's coming in, and maybe you're just monitoring against GNSS.
Right, and you can also ensemble multiple tickers together and then gain additional stability improvements by doing so.
Right, as no, just like, again, we talked about where can ticker go that, existing primary reference technology goes, and it's in those same places. So in the same ways that you can take advantage of multiple clocks to ensemble to improve performance and monitor outliers and things like that, and do the same things with a ticker.
Yeah,
right.
exactly.
Yeah. Here's an interesting business question. How are we dividing the responsibilities in this partnership?
Yeah.
Obviously, I'm asking the questions and Pritesh is answering them. But no. So in general, we have a reseller agreement.
Yeah.
With us. So Infleqtion is producing the tickers. We are selling them and packaging or architecting them into
System level
solutions to deliver for customers.
Yeah. Yeah, the way I look at it is, we're providing that stable frequency reference and all the technology that goes into it, and it pairs really well with Safran's White Rabbit for distribution, time and frequency distribution, and the Secure Sync, which really orchestrates all the failover capabilities. We actually, both Tiqker and Secure Sync now have GNSS input, so we can steer to it. And the nice thing about Secure Sync is that if there's a failover, Secure Sync can be used to manage the entire network, and then switch over to Tiqker or any other reference.
Right. Yep. And in the same way, on the let's say the service side, right? So Safran is providing service on the system, right? And of course, we'll come back to the experts on the portions that apply directly to ticker support and things like that. Yeah. So as we talked about, so it was around kind of stability, accuracy specifications. You said, it's active hydrogen maser like performance.
Yeah.
That's really that takeaway from a performance standpoint.
That's right. And I think this question is asking about both stability and accuracy.
Right. And the accuracy part, it's a primary reference clock. So inherently it's a frequency source, not a phase source, right?
That's right.
So in order to get that phase accuracy, let's say to UTC, you have to use that sync input to sync it to something, or it's passing through as a frequency reference into, let's say, Secure Sync, where the Secure Sync is providing that phase accuracy or phase correction from GPS or GNSS,
right?
Or some other input even. Yeah.
That is the key there, is that in order to achieve the accuracy and UTC traceability, you do need to synchronize to that GNSS signal first. And because Tiqker is such a stable reference, it can maintain it over a long period of time. As we mature our product and start to look at our future releases on our roadmap, we are going to include a GNSS receiver on there, so we can start to offer direct UTC traceability.
Right. So start bringing in some of those say that next step, outside to incorporate internally,
Exactly.
right? Yeah. And then the question on the outputs, the interfacing, we'll just go there. And why not, right? We have that stable laser output, 1556 nanometer. We have the 100 megahertz, 10 megahertz. He's nodding. Going through.
He's got it.
Making sure I get it right. 5 megahertz, 2 1 PPS outputs.
Yep.
And then our synchronization input.
You got it.
And that's all. And then from let's say more the signal level, and then of course there's the user interface for to do the, I'll say the limited setup and control that you have to do for the device.
And just to kind of add to that, we do interface with the system through an Ethernet port. So that's where you can access all the main control either through our API, so you can interface through your own software or use our web-based user interface to basically monitor status, control the system. We also do have a RS-232 port with standard like Skippy commands. And yeah, those are the two main inputs to command and control the system.
We talked a little. I think we talked a little bit about like road mapping. We already talked again about the space qualified piece. What would you say about let's say near term, medium term on the design, on the performance level, things like that? Where you guys looking?
It's an interesting question because we're actively improving our performance on Tiqker Prime almost on a weekly basis right now. So like I mentioned at the beginning, we've gone through 4 design iterations. In the last design iteration, we really focused in on manufacturability and design for manufacturability, and that really improves how quickly we can build these systems. And we really targeted thermal stability on this last design, because thermal stability will directly impact your performance, especially long-term performance. So as we go, we're going to keep making iterations on Tiqker Prime to include additional features like UTC traceability, other areas that we can continue to improve our long-term performance. And as we look a little further out, we look to really just start to reduce the overall size of the system and the cost of the system, as well as aiming for ruggedization, space qualification, and then ultimately chip scale optical atomic clocks is where we want to end up.
Wow, I love that. We talked about already. I'd love to chip scale and just embed all that capability right into the products. Yeah,
right.
It's another one around multiple units is really around the ensembling, and we did speak about that. Of course, as a primary reference, you can use that for ensembling. This one's asking about GPS specifically, but really ensembling can be used with any sort of reference. And
so it doesn't have to be just Tiqkers. We could ensemble with different types of clocks, even the clocks that Safran provide. Another option is you have multiple Tiqkers that are ensembled together, and you can steer to GPS on top of that. So you kind of get the best of both worlds, where you get Tiqker short-term stability, short and mid-term stability, and GPS is kind of long-term stability. And then if and when GPS is degraded or unavailable, then you basically fail over to Tiqker's holdover capabilities.
Yeah, and actually another piece on ensembling, with the benefit of White Rabbit technology and the ability to take the really that performance of the Tiqker and being able to transmit that over distance, you can actually do ensembling, but it doesn't have to be localized ensembling. So you can have that benefit of some diversity in location for some resilience for power or things like that as well.
That's what I was thinking. Is the power grid is a great example of that as we start to expand the different types of applications where it doesn't have to be localized. And if you have one node that goes down, right, through the White Rabbit network, you can fail over to different nodes.
Yeah, timing architecture.
That's interesting. Yeah.
But we talk about, we're gonna revisit applications, so the markets and stuff that we see Tiqker as driving into.
Yeah, I mean, in the short term, it's going to be national security, assured PNT, as well as timing laboratories. But as we start to go further in the 5 to 10 year time frame, then we really start to talk about telecom, data centers, especially space-based timing applications. That's really where we're headed.
Yeah, as we see like the swap improvements, the obviously space is its own kind of its own environment, its own animal, right? So improvements there, that's going to open up that kind of
and I
market
touched on
area.
it with our roadmap right? Where we really want to start to focus on future iterations, which will include ruggedization. So that way we can start to deploy these kinds of systems to mobile applications, and then space qualification, which allows us to expand this whole timing infrastructure that we're deploying on the ground today to space.
Okay, so here's a question that I'm gonna
Okay.
hand off right to you. Right?
Yeah.
So we talk about quantum sensing, right? And referring to Rydberg type EM sensors, such as Dr. Holloway of NIST have been working with. I guess, I mean, I'll hand it right to you. So.
Okay. Yeah, so in Infleqtion in general, we do focus on a broad range of quantum sensors. So Rydberg sensing is one of the types of sensors that we work on. I won't necessarily comment directly to what Dr. Holloway is doing.
Okay.
But yeah, we do have Rydberg sensors. We also have inertial sensors. And timing isn't necessarily a sensing modality, but it does fall under the umbrella of quantum sensing as a whole.
Right, and the Tiqker is that main commercial output at this point, right?
That's right. Yeah, and a lot of what we're doing in Tiqker helps us really mature the other sensors that we're building on.
So here's a question, just a little into the talking about the interrogation. So the interrogation of the rubidium. Explain what we mean versus the hyperfine transition, for example.
Yeah.
When we are talking about that, right? I mean,
that's right. When we say interrogating, we're not like shaking the atoms, questions of them.
Put them under that hot lamp, right?
No, what we basically mean is that we're firing a laser at the atoms and we're exciting them to a particular hyperfine state. So there's two different states. So we're basically at the 5D line with our optical clocks.
Right now, and actually we didn't talk about this before. I didn't have it because this question came up. We say it's a two rubidium arc, a two photon process. That's actually two stages of
that's right.
Exciting, right?
We kind of skip through a virtual state. So the microwave transition happens at a lower hyperfine transition. With optical, we're basically going right through a virtual state to the 5D line that I mentioned.
Yeah. Well, I love it's really interesting technology, and I like I might be able to present that to this audience here. So here's an interesting one. So we talked about the control interfaces, and do we have just on the impact of this on the environment, so like EMI, EMC?
Right. So I think broadly speaking, the answer is no. We actually are in process for a CE certification, which includes testing for EMI emissions. So we actually just passed our first portion of it. So we are within regulatory standards for EMI emissions.
Perfect. Here's a good one. The benefit between using this product and GNSS and the rubidium that we already use within the secure sync. So, and I would say, well, it's not an either or, right? I mean,
depends on the application.
Yeah, it depends on the application where the Tiqker is actually a part of that system and works alongside the secure sync, right?
Right. Yeah, I mean, and this question is also touching on GPS. So if you were just to compare, depends on which time regime you're talking about with GPS, but in short time scales, Tiqker is probably 100 to, if not 500 times better than a standard just GPS signal in terms of stability. So a good way to think about that is if we're talking about synchronization, Tiqker at those short time scales can offer picosecond level sync versus GPS is closer to nanoseconds.
Right. Yeah, and that's just on kind of general usage of GNSS, disciplining and things like that with the oscillators. Is the steering that we do to GNSS is actually to get that longer term maintenance of that of that reference versus what's happening in the short term, and the oscillators are better than GNSS in that short term.
Exactly.
Right. Oh, okay. So it's interesting. Using it's observability, right? On what's the kind of, I guess, the data that you can get from the network interface in terms of monitoring. What kind of things are
Yeah, so
available?
we offer an API that allows our customers to basically connect to the Ethernet port and then process all the data that's coming from Tiqker. So it depends on what you're looking for. We have a base set of parameters that you can pull. So ranging from lock status.
Yes, so the basic ones, right?
Yeah, and just general telemetry, so you understand what's where the system is at, and we can customize it pretty easily for customers depending on what they're looking for.
Okay, I like that answer. Right. Yeah. It's always about that customer experience, right?
Exactly. Yeah.
And then always looking to get feedback from the customers for what they're looking for, what additional.
Some customers may not be interested in reading anything from the API, and others want to know exactly because they're integrating the system into a much bigger system. Right. And so there'll be parameters in there that they want to see that could indicate a potential failure.
So here's an interesting one. Does Tiqker implement anti-jamming solutions?
I think the answer is no.
I think the answer
but
is no, right?
we are. I would like to say we're jamming proof.
Right.
We don't emit any type of RF emissions, so it can't really be jammed. That's the benefit of using lasers.
Right. That's this is what one of those things that Tiqker provides is that that reference you can use in a mitigation paradigm for interference in, whether it's on the GNSS or other side, is Tiqker provides that stability if there are issues on your actual reference that are coming in, right?
Yeah, and I think that one interesting thing here is that we've done deployments on exercises where there's active jamming happening at the site, and we're really just impervious to it. Where really what Tiqker offers is enables applications to not necessarily be jammed.
Right. Yeah. So it's part of that assurance, that resilience that you want to do to complement the.
Yeah. So GPS can be jammed, hence why you would want a local reference like Tiqker.
Yeah, exactly. Suppose a big order comes in, and then everybody cheers.
Yeah,
a big order. What's kind of do you have expandable capacity kind of?
We do. Some of it comes from our partnership with you guys. And I heard David, you really like modularity.
I love modularity.
So we designed the system to be modular. And a lot of the reason for that is so that way we can start to work with contract manufacturers in order to scale our operation.
Right. As part of, we talking about that, those large improvements you made to manufacturability and producibility.
Exactly.
That it's also so that can extend the manufacturing capability as well, right?
You're right. So we're really developing that manufacturing process at Infleqtion first. In order to understand what we want to transfer over to a larger manufacturing company like Safran, or working with our contract manufacturers.
Right. That's an interesting one. It's environmental impacts on Tiqker, temperature, magnetics, things like that.
Yeah, these are very important for us. So we design in order to reduce a lot of the local effects. Right, so how we build up our physics package, which basically has the atoms in it, and where we're lasing it, we do shield that because there are magnetic fields that can induce shifts that can affect stability. So that is already baked into the design. Like I mentioned before, our latest design turn really focused on thermal stability in order to reduce just local temperature changes. Because temperature shifts can impact your stability, right? The lasers have to maintain a specific temperature to maintain that wavelength in order to maintain that stability.
Yeah, it's one of those things that for those that work with frequency reference oscillators, whether they're crystal or MEMS or atomic, temperature is that big impact on what's happening. Now,
right.
If you look at the impact that temperature would have on a a TCXO or OCXO, and you look at what it would have on the optical,
Mhm.
on the Tiqker, they're very different, but
Right.
they are still there, right? And you're talking about that the design, the design improvements, not just for the modularity and the manufacturing, also around some of the environmental protections that you're putting in place to.
Yeah, and that's a kind of a nice choice around rubidium, and even atoms like cesium, where they're neutral atoms, so they can operate at room temperature. So as a company, we've chosen these particular species because we don't have to supercool them and take these heroic steps to maintain our performance.
Yeah, I mean, yeah, it's part of that performance benefits that we get out of this. That the core technology already has this sort of inherent protections, and
Right.
then you build on that around it in the system design, right?
And one thing I'll add to that is, we are on our specification, we basically enable 15 to 30 degrees Celsius that's where we operate at. And so we're actively also working to expand that temperature range.
Okay. So this one is good, and I won't make a note of the time and just repeat that if you do need to leave the webinar, we are recording it, so you can come back and do some of and see some of these answers as we go through. And of course, if we don't get to some of these questions, we are happy to respond to those.
Sure.
Outside of it, and for new questions, of course.
Yeah.
Right. So this one is good on let's say exportability of the Tiqkers, right? So these are producible. We can ship these around the world. The export restrictions are there's not a lot of export restrictions around the Tiqker technology. Of course, end users always come into play when we talk about U.S. export. But if there are specific questions, of course, reach out to us and we can go through, because it does end up being a little bit of a case by case application. And
I mean, what I'll say is that Infleqtion is a global company, so we have offices in Europe as well as Australia, and so there's ways we can service these kinds of requests.
Yep. Let's see. So in terms of distribution, what are your solutions for distributing the timing reference? Oh, we talked right about this, right?
Yeah.
This is the part of this partnership is to, it's not just about reselling and distributing the products, right? The actual signals, right? It is also one of the benefits of this partnership with Safran and Infleqtion, taking the performance, being able to manage that along with other references with like Secure Sync, and then the distribution over White Rabbit, which is our typically over fiber optics. I will say that we've done single hop White Rabbit links up to there's over 100 kilometers that we've done on a single link.
Wow.
And then you can stage those, so you can chain those the White Rabbit nodes to go even further.
What's the furthest you guys have distributed?
So we did the furthest, we did a distribution test between New York and Chicago.
Okay.
Over White Rabbit. So I'm not sure if that's the latest furthest, but that's the one that comes to the top of my head. It's one I use a lot. Let's see. And here, kind of architecture example, can you present with Tiqker as the heart and Secure Sync and distribution over the way? I think that was what we talked about, right? If you were doing, let's say, GNSS independence, you could have Tiqker as the primary reference to this whole timing architecture, where Tiqker feeds into Secure Sync and then distributes out to the end nodes over White Rabbit, or other technologies if you have. And
Yeah, a good application of this could be, distributed sensing, where you want to synchronize disparate sensors on a single time base. So for example, there's passive radar techniques like time difference of arrival, where Tiqker could be the heart, and then using White Rabbit to distribute to passive receivers, where if you have an emitter coming into your field, you're able to pick up the different times it's hitting those passive receivers, and then you can do geolocation based off of that. So that's a perfect example of how you would use Tiqker plus Secure Sync plus White Rabbit to drive a sensing system.
Yeah, so a big, it's about passive radar, so those multi-static radar installations.
That's another one,
for radio telescopes, the distributed radio telescopes.
That's right.
That you're using. Those are all architectures and applications where taking the performance of Tiqker and being able to distribute that and utilize that at multiple nodes at distance.
Right. Yeah, and the biggest benefit there over standard solutions is that now we can synchronize all of the nodes in a multi-static radar system to picosecond level, which directly translates to reduction in your positional error and velocity tracking.
So it's a sort of leading question. What are the reference input types that Tiqker accepts?
Reference input types.
So what does Tiqker take as an input? Or what can it take as an input?
Oh, I see. It basically could take anything that provides a 1 PPS signal, right? So I think broadly speaking.
Yeah.
And generally what we've talked about here today is using a GNSS signal to steer Tiqker to, but it doesn't have to be that. You could also pair this with a hydrogen maser or a fountain clock, or anything that potentially is better than Tiqker.
Right. So that sync input is really like a PPS input that can come in that register too. And then that next piece out can be almost anything that can provide that PPS, right?
Yes, right.
And that's really what drives that capability is that piece. And so, as you said, you might bring some of that reference capability, that first tier reference capability, like a GNSS receiver or something like that internal.
And this is how you would basically ensemble multiple Tiqkers together too.
Yeah. Here's how much can get into the application, but what was some of the defense demonstrations that you guys did? If you can talk, in more. Revisit a little bit.
Yeah, some of the public demonstrations that we've done, one was with the UK Navy that we recently published. We basically put Tiqker on an unmanned submarine. So that's a perfect example of where you need a timing source. You really can't rely on a GNSS signal.
Yeah. It turns out GNSS doesn't penetrate the water very well.
No. So, and then broadly speaking, some of the applications we just talked about, like multi-static radar configurations or time difference of arrival, like those passive types of techniques. Like I said, we've also done deployments for the defense sector in heavily jammed environments, right, where you're not going to expect to get a GNSS signal there.
Right. So the parameters of the 1556 nanometer laser. So from a performance standpoint, that's what drives that output is coming from that stable locked laser internally. So this is asking about performance of that. The performance of that is some of what drives the performance of the entire system, right?
Yeah, the way I would look at it is effectively we're locking that 1556 laser to the atoms. And so we have an entire control loop based off of that. Then once that's locked, we take that signal and then using the optical frequency cone, convert that down to RF. But we can, like we said, we pass it onto the back of the chassis, so you can use that locked laser.
Right. Do you have some application where they are using that laser specifically versus some of the the microwave outputs?
Yeah, from a quantum computing standpoint, they can leverage that in order to lock the lasers. We've actually leveraged it previously to lock a strontium ion clock before,
interesting.
too. So
Yeah.
because it was faster to do it that way, and because the strontium ion clock, it's, well, one, it's a higher end clock, but there's a lot of different lasers in the system at different colors. And so it was efficient to use Tiqker to actually lock those lasers.
Oh, interesting.
Yeah.
So we talked to some of this to see a lot of common questions here. So here's a question of steering or controlling the Tiqker.
Mm-hmm.
Maybe some comment around what you guys are doing with the sync input right now.
Yeah, so as I mentioned before, we could take a GNSS signal directly in, and Tiqker will essentially be better than a GNSS signal almost out to a week, at which point, over time, that GNSS signal will start to average down below even what Tiqker stability is. So this is a perfect use case for frequency steering, basically, where we get the benefits of Tiqker in the short and medium term. And then as the GNSS signal starts to average down below, we start to steer Tiqker to that signal. So you get just a much better clock overall.
And so that algorithm that's there is actually internal to the Tiqker.
Yes.
That will be
right.
Doing that steering.
Right. Essentially, it's an automatic piece that you would enable through the user interface. So all you really need to do is just plug in your PPS signal directly into the back of Tiqker.
Okay.
Lots of questions here.
I know. I love this. So here's an interesting kind of roadmap for a partnership roadmap kind of thing is, so White Rabbit, the optical clock performance is, it's amazing performance. And you guys, you're welcome. And as part of what you're saying with the roadmap is always looking at, improving that performance and the stability. When we did our testing and doing distribution of White Rabbit, we saw that White Rabbit was right about that level of maintaining that level of performance, right? And so I'll say on our side, as that performance improves, we are also at the Safran side also looking at performance improvements in White Rabbit, in our other distribution capabilities, so that we can keep up with the performance levels of the references that we're using, so that we're not degrading the performance of our primary references when we're distributing out. So it's on both sides, we're looking at performance improvements to that scale, so that we can maintain what references like Tiqker are doing as we distribute out.
I think, correct me if I'm wrong, but I don't think you guys have had to face that yet. So
yeah, it's one of those. It's like we in our primary reference GNSS, White Rabbit is much better than what GNSS is providing.
And so if we're able to improve White Rabbit performance, we could go from talking about picosecond level synchronization to femtosecond level sync.
Yeah. I think we'll take another question or two here. And then this is actually, what are Skippy commands? For those in the know, right?
It's SCIP commands. So basically, it's a kind of an older format for legacy systems that allow you to just communicate over a RS-232 interface.
Yeah, so it's just a standard communication protocol. It might be a little bit a older, but it's still in use.
Yeah, I mean, I think we find most customers tend to use just the web-based user interface. This is just another option for legacy customers.
Okay. And then I think we'll take a last question here and then wrap up. Here's about in data center applications.
Yeah, how do we actually help data centers? A lot of it just comes, again, through synchronizations, right? Where you're not going to be running or training a model on necessarily just one server rack, right? This would be distributed across server racks. And it's not just model training, it could be, data transports. But this is because it happens across multiple servers, you need a way to have a common time base for all those in order to basically time align all of the operations that are going on.
Yeah, so that when in just the same way with that short-term stability is,
Right.
Okay, I can get the measurement, the difference between those actions, those activities across the distributed space, more tightly measured.
Right. It's
so that
precise timestamping.
Yeah,
is
exactly.
really how you would help a data center.
Okay. Well, Pritesh, thank you for joining me on Sick with an Expert here.
Yeah.
Thank you.
Thank you for having me.
Oh, absolutely. And well, it's a great number of questions, great topics that we had. Again, if we didn't get to your question, you have questions after this, please contact us. We love reaching out and talking with customers and talking about these applications. We have a link to go to our website and fill out a form, and then we can come back to you. And with that, I'll pass it back to Nadine.
Thank you again to everyone who joined us today. And a special thank you to Pritesh, Dave, and the entire Infleqtion team for welcoming us to Boulder and helping bring this exciting partnership to life. This episode has been a great opportunity to show what can happen when innovative quantum timing technology and Safran's trusted synchronization solutions come together. For customers who rely on precise, resilient timing, this partnership opens the doors to a stronger, more dependable timing architecture designed for today's increasingly complex environments. Before we close, you will see one final poll on your screen asking if you would like a member of our team to reach out. If you're interested in learning more about Tiqker, Secure Sync, or how this combined solution could support your timing needs, please let us know. You will also find links to share your feedback on today's webinar, or you can get in touch with us directly. And as always, we truly appreciate your time, your questions, and your interest in this special Sync with an Expert episode. Thank you again for joining us, and we hope you have a wonderful day.